Hey everyone, in last video we set up cursor on our local machine, reviewed its important features and prompted it to produce a rudimentary app where we are making this API call to OpenAI's model. Now AI models are not deterministic, meaning even though you might have used the same prompt and same model that I used, it's likely that your machine might have a different code output from the AI model. However, it will at least have this particular API call being made to OpenAI. So let's dive into this completions API call that we have made to OpenAI's model. Okay, let's add this selection to chat, and as you can see, the context of our selection has been added. And at this point, let us ask model to explain this code snippet. And right when I was editing the last video, Anthropic released Claude 4.5 Sonnet. So we will ask Claude 4.5 Sonnet to explain this code snippet. And as you can see, it's telling us that this snippet calls the OpenAI's API to generate a chat completion response. And the model that we are using is GPT 3.5. This is where we are passing the user query to the model. And we are also constraining the maximum size of our input request, as well as deciding how creatively AI should respond. You can see here, the lower the temperature, more deterministic the response, and higher the temperature, AI will tend to be more random and creative. Now, right off the bat, you must have noticed that we are hard coding the model here, and it makes sense to not just let user pass in the query that they want to send to the AI model, but also select the model itself. Now, in order to test different models and what parameters are possible with those models, let us go to OpenAI's chat playground. Okay, so you can Google OpenAI playground and select OpenAI chat playground. You will land at this interface. Then select chat completions API if it's not already selected. So OpenAI has two different APIs that we can use to make calls to their models. One is responses, which is relatively new API, one which OpenAI recommends for all the new projects to use, but we will discuss that part later. Okay, for now we'll keep using chat completions API, and down the line we will substitute it with responses API. So select chat completions API. At this point we can now check out different models that we have available here. Okay? And as you can see, GPT 3.5, the model which we have currently hard coded, is actually one of the older models. It came at around 2022, which, even though it's not that old, but on AI timescales it's kind of ages. I doubt there are any production grade projects which are even using GPT 3.5. So let's select GPT-4. Okay, OpenAI as well as other frontier companies broadly offer two different kinds of models: reasoning models and non-reasoning models, and GPT-4 is an example of a non-reasoning chat model. All large language models are trained to predict the next word given a set of words. Okay, so imagine if human beings are given a math problem. Generally how we approach it is we divide it into smaller discrete subtasks and spend significant energy solving each of those subtasks, eventually solving the final problem. Reasoning model are trained similarly in that their training data tends to have either math problems or coding problems that have definite answers, and then they are trained to produce chains of thought or trajectories of thought leading up to the right answer, but they will be spending a lot of compute solving intermediate tokens or intermediate answers before giving you the final answer. And then you implement reinforcement learning on the top of it to reward the trees of thought or chains of thought that produce the correct answer over those that don't. Now, non-reasoning model like GPT-4, for example, can produce multi-step thinking, but it won't do it by default or reliably like reasoning model because they're not trained to do that. In fact, let's look at the example of the difference between reasoning and non-reasoning models. Okay, so let's go to ChatGPT. In this case, I'm using, in fact, let me use one of the legacy models. Okay, so let's use GPT-4o, which is also a non-reasoning model. So let me ask it to explain reasoning and non-reasoning large language models. What's the difference between them? Explain with examples. We are asking a non-reasoning model, which is why you don't have a thinking or deliberation step here, and you will see it when we ask the same question to GPT-5, okay, which is a reasoning model. Response is telling us the distinction between reasoning and non-reasoning large language models lies in how they generate responses, particularly whether they simulate step-by-step cognitive processes or reasoning. For example, a math problem, dividing it into different discrete subtasks and solving each of them, or simply rely on surface level next word prediction, which is what non-reasoning model do. And as we can see, reasoning models have chain of thought reasoning, multi-step logical thinking. They have internal scratch pad, which they use before producing the final answer. Okay, as you can see, non-reasoning large language models are basically statistical language modeling exercise where they engage in next token prediction without breaking the task into intermediate steps. Now let's ask the same question to GPT-5 and let us keep GPT-5 thinking. So we'll actually see the reasoning steps involved when model tries to think about it and then produce a final answer. So as you can see, it's already thinking. So that's a point of difference between a reasoning model versus non-reasoning. It's not jumping onto the answer directly. And if you click on this thought for 17 seconds, it will give you the internal deliberate reasoning that model is engaging in before giving you the final response. The model is thinking about intermediate steps here. Okay, so now let's go back to our chat playground. So as you can see with GPT-4, which is non-reasoning model, we have this parameters. The parameters which we will focus on for now is temperature as well as tokens. So these are the two parameters, temperature and tokens, which we have as of now hard-coded in our API call here. Then we can check out some other non-reasoning models like GPT-4o. And similarly, it also has temperature and tokens. If you select one of the reasoning models, or O-series models were the first reasoning models which OpenAI came with. So let's select any of this. We can select O3, which was my favorite reasoning model before GPT-5 came along. Now in this case, we don't have temperature or tokens. Okay, what we have is reasoning effort. So that's something to keep in mind, that for reasoning models, it's not temperature that we fiddle with if you want to decide how much effort the model is making or how creative it's being. It's the reasoning effort parameter. And same will be the case even for the later GPT-5 series models, where it's reasoning effort parameter which will decide essentially the amount of compute that the large language model will spend for inference. So a lot of these models, whether it's GPT-5 series or GPT-4 series or O series, will also tend to have mini and nano versions of the same model. And the difference between them is that GPT-5, for instance, will tend to take a lot more time thinking or spending compute before it gives inference. Whereas GPT mini will be faster than GPT-5 and it will compromise a bit on intelligence and reasoning. Okay, so it will make less reasoning effort than GPT-5 and give you answers faster than GPT-5. Similarly, GPT-5 nano will be even faster than GPT-5 mini and will spend even less reasoning effort and compute than GPT-5 mini. And this is true for all the series, right? So oftentimes what happens is mini and nano are basically reserved for tasks that are slightly less complex, where we don't need to spend a lot of effort reasoning. So let's go back to, say, GPT-4 mini in this case. So we have selected GPT-4.1 mini. We can tune the parameters here by selecting, say, if we want to select 1.2, okay, or 1.5 rather, we want our model to be a bit more creative. We'll keep maximum tokens to be 5,000 and let us add our user prompt. What's the capital of Netherlands? Responded with the capital of Netherlands being Amsterdam. Now there is another parameter which we can tune in context of large language model, and that is system message. You can think of system message as high level instruction that help us guide general model behavior. Okay, so imagine in this case, for example, okay, let's delete this and let's ask the same question to the model. What's the capital of Netherlands? And in this case, let's also prompt it to provide a detailed answer with a fair amount of geopolitical and historical perspective. Okay. And as you can see, it's telling us the capital of Netherlands, but it's also offering a more detailed rejoinder because we prompted it to do so. So usually prompts like this, where we are tuning a certain behavior when it comes to the response from our large language model, should be passed into system message, because it's not just while asking for capital of Netherlands, we want this kind of response. Maybe we want this kind of detailed response, even if we ask for capital of some other country. So in cases like this, we'll take this prompt, okay, and instantiate that in our system message. So let's again delete this and let's have our system message as, you are an expert in geopolitics and history with tremendous penchant for giving detailed answers to user queries. So we have created a persona of someone who is an expert in geopolitics and history and always likes to give detailed answer, and this will be true for all the prompts that we pass to our model. So now we don't need to prompt it to give us detailed answer. We simply need to ask it what's the capital of China. Okay, and our expectation is that because our system message is asking for a detailed response, it won't just give the capital, but it will also give some more details of it. Okay. In this case, the details are less. We can add this part. So not only give detailed answers to user queries, but also provide appropriate geopolitical and historical perspective. Okay, so now let's ask it what's the capital of United States. And as expected, it is giving us a detailed answer along with the name of the capital itself. Now let's repeat the same exercise for reasoning models also. So let's go to GPT-5, delete this. Notice that instead of system message, we have developer message. So now OpenAI has, especially the chat completions API, has this difference between reasoning model and non-reasoning, in that instead of system message, reasoning models tend to have developer message. I think we can pass system message to OpenAI's API even for reasoning models, but just to be safe, anytime we are using reasoning models, we will use developer message to guide our model behavior, and in case of non-reasoning models, we'll use system message. So let's repeat this exercise for GPT-5 by asking it the capital of India. Now in this case, the model will be slower than non-reasoning because it has involved in some thinking, okay? And as expected, it has given us a capital as well as detailed historical perspective. We can also tune verbosity parameter because our response is a little less verbose than what we had in case of GPT-4. So we will tune this verbosity to be high, and we'll ask it again the capital of India, and expectation is that this time the response will be detailed or more detailed than it was last time. Yeah, and as we expected, we have a more verbose response, okay? So now that we have fiddled with a few important parameters, including model selection, you can also read up more about OpenAI models by going to OpenAI's models overview and checking out their documentation, right, which is fairly detailed. For example, if you want to check out pricing of different models, here we have pricing in terms of both the input pricing as well as the output pricing per 1 million tokens. So in case of GPT-5, for example, if your input request has 1 million tokens, then it'll be charged $1.25, and 1 million token output will be charged $10. So again, always useful to remember that you will be charged not just on the size of your input message, but also your output message. And you can just do comparative analysis of pricing for different models and then see which models to use for testing as well as which models. So generally, the more costly the models, the more you want to use them in production. So I generally tend to use GPT-4 or Mini especially a lot. Because as you can see, it is 15 cents per 1 million tokens. So I use it a lot for testing. You can also explore detailed aspects of each of those models here. So GPT-5, for example, has 400k context window and then 128k max output tokens. And then you also have the knowledge cutoff. So it was trained on data, on public internet data before September 30th. So if some important event happened on October 1st of 2024 onward, very high likelihood that it won't have any understanding of it unless you provide it external context of that event. So now that we have tested different parameters and different models, let's construct a prompt so that we can redesign our API to account for that. So user can select the model, pass in a user query, select maximum tokens, select temperature if it's a non-reasoning model, or reasoning effort if it's a reasoning model, and then maybe also verbosity. So let's spend some more effort creating our prompt this time around than what we did at the start of this application. I'll create a new file here, prompt.txt. Our prompt will be, we want user to have the ability to select which model to send queries to and choose from below models, label them as reasoning or non-reasoning for user. Then I've already selected this list of models that we will be exploring here, and it includes a healthy mix of both reasoning and then non-reasoning. We also want user to have ability to choose temperature for non-reasoning models or reasoning effort for reasoning models and maximum tokens, okay? Then as we discussed in context of system and developer message, user should have ability to give instructional role as developer message again for reasoning models or system message for non-reasoning model, okay? And then user should be able to change parameters at any point during chat session, okay? And user should be able to quit at any point during chat session. Save it, and this looks good. So what we'll do is we will add this to our chat session, and as you can see, our AI has this context now of our prompt. We will just say do this. And as you can see, it has started its chain of thought reasoning, add model selection with reasoning, non-reasoning labels, and it's currently trying to modify main.py file. See, right after that, it has queued up different steps to add dynamic parameter configuration, then add instructional role, then user should be able to change parameters, update UI with commands. This will mostly be command line interface because we have not yet created UI. So as you can see, it has already made diffs into main.py. It has added 258 lines and gotten rid of 27 lines. So let's open main.py to check out the changes. As you can see, it has now created dictionary of models with reasoning and non-reasoning keys. It has created a class chat config. Okay, my guess is that this is how it will instantiate chat config class and then modify its parameters down the line based on whatever the user inputs from command line. Okay, so it has if self.instructional message, then for reasoning model we will append it as a developer message, for non-reasoning as a system message. Oh, it has actually created a chat model. I only wanted to create a single chat session, but it seems to have also created the logic for extending the history. So this is where we append the user query after adding the instructional message, and then this is where we have our instructions for changing parameters. Print models, print configurations, okay, reasoning model, then it's reasoning effort which we want, and otherwise we want temperature. Okay, instructional message. Then we have handle command method where, okay, what is it trying to do here? Okay, so this is basically all the instructions for user, right? So this all instructions that we had. So basically if we type help, then it will print out all the instructions here, right, in terms of how to proceed and how to configure or change different parameters. And then this is where we are selecting the models, right, based on whatever user selects. So if it's fairly aesthetic also in terms of its output and how it will appear on the command line. Then obviously it has a different mode of initialization now that we have the chat config class. So we have deleted these lines as well as this API call. Oh, interesting. It actually is unpacking the dictionary while making call to the completions API. Not sure I like that approach, but we'll just go along with it. So it has created parameters here in API params dictionary, and then it's unpacking those model messages max tokens parameter using this snippet. Okay. Then this is where we have our response. So far what we have done is we have basically asked a question to the AI model and then captured its response. But what this logic will also do is it will actually extend the conversational chain and it will preserve it. So unless we quit and close the session, it will actually remember all the previous messages because we are storing it and we are passing it. And this is where we are returning the AI message. And this is where we are starting our chat session on the command line. Okay. This is our chat config class. This is our OpenAI key. Now this is more complex than what I expected, but looks like it should work. So we'll keep all these changes. Okay. And now let's go through the other changes that it might have made. So it has obviously made some changes in the README file. We'll accept that also. And again, if you want to look at the preview of README file, you can select that option, go through the README file or close this part. So I have successfully implemented all the requested features. Here's what has been added. Model selection, you can choose from 11 models, 5 reasoning, 6 non-reasoning. Then we have the option to customize our parameters, add instructional messages, and then get runtime configuration as well as any help or command reference. So looks good. Let us start our terminal session and UV run our main.py file. So let's first use help to see what commands we have available. Using models, we can find out the list of available models. And as you can see, we have this many reasoning models and these are non-reasoning models. And then if you want to select any models, we will basically be doing this. So say if we want to use O3, the reasoning model, we will use models O3, model set to O3. Okay. And then in this case, we will set reasoning effort to high. Okay. We will set effort to high and reasoning effort set to high. What other things we want to modify? We want to modify instructional message in this case, right? We'll keep the max tokens to 1000. We don't want to change that. And we will change instruction. You are an expert on geopolitics and history that has detailed understanding of nation states and civilizations. You always answer in detail, giving the user proper perspective. Right? So we have set our instructional message, and in this case, because it's a reasoning model, we have set it to developer role. I think that's it for now. We can just now submit our query. So we will be asking it, what's the capital of Netherlands? And at this point, I'm assuming it is okay. So we have an error here that it's an unsupported parameter. Max tokens is not supported with this model use. Right. Okay. So it seems like with reasoning models, we can't use max tokens. We have to use max completion tokens. So at this point, we can go to the part of our code where we are making the API call, right? It was a part where we were unpacking our API params dictionary right here, right? And instead of max tokens, we might have to change this to maximum completion tokens, but only in case of reasoning models, because I'm assuming that for non-reasoning models, it might still prefer max tokens. So we can either manually change that, or we can capture this error, ask our AI model to resolve it for us. Okay. some models, reasoning models in this case, use max completion tokens instead of max tokens. So it has deleted max tokens from API params. It's passing it right here. So max completion tokens. And in case of non-reasoning models, it's still preserving max tokens. Changes look good. So we'll keep it. We will be quitting from here. We'll be clearing this. Let's UV run main.py. We'll have to basically repeat the same process. So we'll select model to be O3 and we will select effort to be high. We will select instruction. It didn't set it because we spelled it wrong. Okay. Maybe we should have an error message if we don't set a parameter properly. Okay, so instructional message set to developer role. Now it should work. So what's the capital of Netherlands? Okay, and at this point we are waiting for the response from our AI model. And as you can see, it has responded under the Dutch constitution. The capital of the Kingdom of Netherlands is Amsterdam, along with some other details. Also, one thing that we should note is how important our instruction is when it comes to guiding model behavior. So for example, if you want to do something funky, like let's change the model first. So let's change it to one of the non-reasoning one. GPT 4.1 should be in our list of models. Let's check out our list of models and we have GPT 4.1. So we can select GPT 4.1 and then we can pass the instruction. But in this case, we will be a little funky. We'll say you always answer in detail like a pirate. And in this case, because it's a non-reasoning model, instructional role is that of a system and not a developer. And let's ask it, what's the capital of India? And we are expecting it to provide a proper expert answer, but like that of a pirate. I mean, I'm not even going to try to say this part out loud with my Indian accent. I'll just end up butchering it. But you get the gist of it, right? That it has still provided us the correct answer with a fair amount of details, but it has done so like an expert who is also a pirate. So instructions are very important, especially in production grade projects where we want to keep steering our model behavior to appropriate direction, where we just don't want an answer. We also want an answer in certain format, in certain way, in certain context. Okay, and all of that is generally set as a system message or as a developer message. Let's quit our application, clear this. Before I end this video, I just wanted to show one more feature of Cursor, which we already discussed a little bit in our last video. So we have this lines of code where we are appending our instructional rules to the prompt that we send to AI model. So let's select this part, select quick edit, and it will open an inline conversation where we can pretty much do similar things that we did on our chat window, but it's more localized to our selection and to our local file. So in this case, we will just ask our AI model a quick question to describe different kinds of roles for chat completions messages. And as you can see, it has responded that there is a system role which sets overall behavior and context of the assistant. There is a user role which represents end user input or queries. There is an assistant used for AI generated response. There is a developer used to guide reasoning models with special instructions. Intuitively, developer and system are same, except system messages for non-reasoning behavior and developer messages for reasoning behavior. I'll close this. That's it for this video. Thanks for watching it.